Welcome back. We're up to lecture 13, and the topic today is moderation analyses. What I'm going to do is show you examples of moderation conducted via multiple regression. So the lecture is divided into 3 segments. In the first segment, we'll walk through one entire example of moderation. They're sort of complex, so it'll take us an entire segment to get through one example. In the second segment, we'll deal with some sort of tedious details, some sort of housekeeping that's involved in moderation, and that's the idea of centering predictors. And then in the third segment, we'll rerun that model or that example from segment 1 after we've centered our predictors and see how it changes. So let's look at one example of moderation in this first segment. So the topics this week are moderation and mediation, which are both complex analyses that utilize multiple regression. And this is probably the most difficult week of this course. And it's the most advanced material I cover in an intro or introductory stats class. And most intro stats courses or textbooks don't cover material this complicated. But I think it really works to show how multiple regression is working to do these 2 different kinds of analyses. Because as I said, they sound the same, moderation, mediation, but they're used to test very different hypotheses. So you can answer very different kinds of questions with moderation than you can with mediation. So that's why I like to present them in one week together after covering multiple regression. But don't get confused and do as best you can to keep them separate. So in lecture 13, it's all about moderation. In lecture 14, it's all about mediation. And then in the lab, we'll show you how to do both analyses in R. So I've provided these little graphics that look a little silly, but again, I'm doing this to help you wrap your head around the difference between moderation and mediation. And here's an example of a moderator sort of in a business meeting. So the moderator sitting down here in front is in charge. The moderator has influence over the relationships of everybody else at the table. And that's what the moderator variable in a multiple regression analysis will do, is it has influence over other effects or over other relationships. Whereas a mediator is sort of nicer, right? A mediator is designed to sort of explain a relationship. So if we have a relationship, say, between a predictor and an outcome, the mediator is introduced into the regression model to try and sort of account for why that relationship is happening. That's a very different kind of question, and we'll cover that in the next lecture. So the example I'm going to use throughout the week for both moderation and mediation is the idea of stereotype threat. So this is an example that comes from social psychology, and the idea is if you bring students into a testing environment and you tell them that the test they're about to take is really important, imagine some sort of admissions test to get into a college or professional school. If you tell them that this is a really important test, it's diagnostic of your ability, oh, and by the way, women tend to perform worse on this than men. If you just say that, then that will have an effect on women's performance on the test. Just by introducing that threatening environment, stereotype threat will have an effect. This is well documented in psychological research, and there have been many demonstrations of stereotype threat. It doesn't have to be men versus women. Pretty much any stereotype, any negative stereotype threat that exists, you can induce that before introducing some sort of test or asking participants to sort of perform in some way or another. So the example will be stereotype threat. That's our predictor variable. And notice that this is an experimental this is experimental research, in that we have a true independent variable. We're going to randomly assign people to either a threat condition or a control condition. And then we'll see how well they do on an IQ test. And the idea in this example is that maybe working memory capacity moderates that effect. And there's actually some research recently to suggest that this is the case. So we know, for example, that working memory capacity, basically your short-term memory or your attention skills, are a strong predictor of your intelligence. So maybe it's the case that if you have a really strong working memory, then maybe you can buffer yourself from this threat effect. Maybe you're not impacted by it because you have such a strong working memory, it's not going to bother you. So that would be a moderation effect. That is, the moderator can say, wait, no, stereotype threat works for those people, doesn't work for these people. That's the idea of a moderator. So when should you do a moderation analysis or introduce a moderator variable into your regression model? Well, I'm going to use Z to differentiate it from the other predictors, X. Let's introduce a moderator variable in situations where it enhances the model, and it'll enhance the model if the relationship between X and Y differs as a function of Z. Right? So in our example, what I was saying is we have the stereotype threat effect, but maybe it differs as a function of working memory capacity. So maybe it exists for people on the lower end of working memory, but maybe it doesn't exist for people on the higher end. If that's the case, then we should introduce that moderator variable into our model. It will enhance the model. We'll account for more variance in the outcome. And again, this is an example of experimental research because our predictor variable X is a true independent variable. I'm bringing people into a lab, randomly assigning them to a threat condition or a no threat condition. What the moderator variable implies is that the effect of the independent variable on the dependent variable depends on Z, the moderator. This is also done in correlational research, so actually it's probably more common to see moderation analyses in correlational research. So let's assume you have some relationship between X and Y, so a correlation exists between X and Y. If there's a moderator, then what that implies is that correlation that you observe between X and Y, it changes as a function of Z. If that's the case, then adding in the moderator would enhance the regression model. And note that if X and Y are correlated, going back to simple regression, simple point, if X and Y are correlated, then if we know a person's score on X, we can predict their score on Y. And there's the regression equation. The regression coefficient is the slope relating X to Y. It represents the relationship between those two variables, right? But here's another red caution. If there's a moderator, then what that implies is that the regression coefficient is not representative of all people in your sample, right? It's not representative across all values of Z because the moderator is saying, wait, the correlation changes as a function of Z. So this is an important point to keep in mind, especially whenever you're sort of consuming correlational research or regression analyses. It's always possible that there's a moderator variable out there that the researchers didn't test, right? So always bear that in mind, that the regression coefficient relating X to Y represents the relationship for that sample and only for the variables tested. So let's look at the moderation model, or how do we set up the regression equation to test for moderation. I'm going to show you this two ways. First, if both X and Z are continuous variables, then it's actually a little easier than the example we're going to do. I'm going to give you the hard example. So if X and Z are continuous, then it's just this. We have two predictors, X and Z, and then we take the product of X and Z, and we throw that in as our third predictor. So if you're working in R with data frames, you would just have to create a new column that's literally the product of x and z. And again, remember, if you go back to the GLM lecture, this is how we trick the GLM into testing nonlinear effects, right? So the GLM, this regression equation, doesn't know that our third predictor is a product. It just takes another column out of our data frame. But it is a product, so what it's doing is testing a non-additive effect. That is, if B3 is significant, that suggests we have a moderation effect. It's slightly more complicated if we have a categorical predictor with a continuous moderator variable. And that's the example we're going to walk through in this segment, right? Our predictor, our main predictor, is stereotype threat. And I'm actually going to make it even more challenging. So rather than just have a threat condition and no threat condition, I'm going to show you two threat conditions and a control condition. So we're going to have three levels of our independent variable. And again, that's categorical. So how do we represent a categorical variable in the GLM, in a regression model? Well, that's dummy coding, right? We covered that with the GLM in the last lecture. So if x is categorical, then we have to introduce dummy coding. And that's what I've done here in the first line of the model. Note, I'm assuming 3 levels of x. So we're going to need 2 codes. And then to represent moderation, it's not just one product, it's 2. Right? So we have to take d1 multiply it by z and d2 multiply it by z. So I put that on a separate line to sort of show you that the first line is just what I'd call main effects of x and z. And the second line is testing the moderation effect. So when we look at the output, what are we going to look for to know if this moderation effect is significant? Well, what we're going to do is run 2 models. So first, this is how you would do it if x and z are continuous. Run model 1 without the moderation term, and then run model 2 with it, and then compare the models. See, did you improve the model fit? If so, then you have a moderation effect. In this case, it's real easy. You could also just look at the regression coefficient associated with the product term and see if that's significant, right? If that were the case, then you can just say, yeah, I have a significant moderation effect. Or you could compare the 2 models. Same thing in the example we're going to walk through. If x is categorical, z is continuous, we're going to run a model 1 that doesn't have the moderation effect, and then 2, we're going to put in these 2 extra predictors that carry the moderation effect. Here we can't look at one regression coefficient because there's actually 2 that carry the moderation effect, so we have to do this model comparison. So what we'll do is we'll compare models 1 and 2 in terms of the overall variance explained in the outcome. So remember, that's r squared. R squared is the variance in our outcome explained by the model. So we can look at how much variance did model 1 explain, how much did model 2 explain, and compare those values. And there's actually an NHST that does that for us, and we'll show you that in the R output. So we can make the statement that there's a statistically significant change in the overall variance explained when adding in the moderator. Again, you could also just evaluate the regression coefficients associated with the moderation terms. And again, in the continuous by continuous case, that's real easy. There's just one. It's a little bit more difficult when you're doing a categorical, and that's why I wanted to use this as an example, because there are 2 terms, and therefore 2 regression coefficients that you have to evaluate. So back to the example, we have stereotype threat. We're going to look at how stereotype threat affects performance on an IQ test, with the idea that maybe working memory capacity moderates that effect. So this is sort of all made up. There's a graduate student in my lab who's actually doing research exactly like this, but we just made up data to make it simple. So imagine that students came into a lab and we just first had them perform a working memory test. Then we randomly assigned them to conditions. And again, to make it interesting statistically, I made 3 levels of this independent variable. 2 threat conditions. One I call explicit threat, the other implicit threat. And we'll compare that to a control condition. So people in control conditions in these experiments, they're not told anything about whether the test is diagnostic of abilities and whether there are group differences and so on. And the explicit-implicit difference, that's also been done in real research. So you can be really explicit about the threat, sort of as I sort of presented it. You could be really over the top with it and tell people exactly which groups are affected, and this is really diagnostic. Or you could just be sort of implicit and say, well, this is diagnostic of math ability, but not really say anything about which group is affected negatively. And even when you do that, you typically see threat effects. So let's have 3 levels. It makes this analysis much more interesting and a little bit more difficult to interpret. And then, of course, we have them complete the IQ test after the threat manipulation. Remember that the experimental condition is categorical, so dummy coding is required. We have 3 levels. An obvious choice for the reference group is the control. So we'll make the control the reference group. Let explicit threat be D1 and implicit threat be D2. So let's start by looking at some summary statistics. When you're doing a complicated moderation analysis like this, it's always important to keep the basic summary statistics and the correlations on hand, because when we start to look at the correlation coefficients, when we start to look at the regression coefficients in the moderation analysis, it can get confusing interpreting those coefficients. So we want to look back to these basic summary statistics to orient ourselves as we look through the results of the moderation. So what I've done here is in R, I just ran the describe function, but I did describe by. So I did describe by condition. We have 3 conditions: control, threat 1, and threat 2. And what you can see, I know there's a lot to look at here, but the main thing we want to see is, did the threat manipulation work? And it did. So if we want to focus in on IQ for the control condition, we get a mean of about 100. It's 97.88. But if you look at the mean IQ for students in the threat groups, they're really low. We simulated these data, right? And we exaggerated the effects to make this look really strong in our graphics. So we can look at the mean IQ for threat 1 is right here. That's about 52. And mean IQ for threat 2 is down at 48. So these are really, really strong threat effects. These are stronger than what you would actually see in real research. Again, we simulated this and made it a little stronger to emphasize the moderation. It's also important to look at the correlations by group, because I didn't really set up moderation this way, but what a moderation predicts is that the correlation between X and Y, between the predictor and the outcome, will change as a function of group. So that's exactly what we see. So just by eyeballing these correlations, I know that this moderation analysis is going to yield a significant moderation effect, because look at that change in correlations. There's a really strong correlation between working memory capacity and IQ in the threat conditions, but not in the control condition. Again, I'll explain why that happens when we get to the end of the moderation analysis. So here are the results from Model 1. Remember, Model 1 doesn't include any moderation terms. It's just looking at the relationship between working memory capacity and IQ and the effect of stereotype threat. Remember, stereotype threat is a categorical predictor, so we had to dummy code it. So that's why the LM function in R looks like this. IQ's the outcome, working memory is a continuous predictor, so that just goes in there. But then we had D1 and D2, the 2 dummy codes that represent the 3 levels of the categorical predictor. Now if we jump down to the coefficients, what we see is a regression constant of 59.78. What does that mean? Well, that's the predicted score on y when all x's are 0. So it's the predicted IQ for someone who got a 0 on the working memory tasks, so that's really bad, and someone who's in the control condition. So that's why it's such a low estimate. An IQ score of 59, right, is really, really low. What's more important here is the effect of stereotype threat. Again, there's a really dramatic negative effect of threat. And if we shift over here to the t-values, right, the really big t-values, you typically don't see t-values like this in real research. And those p-values, you have to go out to 16 significant digits. It's p less than 0.0000. It's a strong, strong effect. And again, we made that up to exaggerate the point. Now let's look at model 2. This is where we add in the moderation terms. So up at the top, if you look at the LM function, we've now added in the product of working memory in D1 and the product of working memory in D2. Now let's jump down to the regression coefficients. What's most important now is to look at just those moderation terms. So 0.4716 and 0.3288. And this is where it starts to get a little confusing. What do those things actually represent? Well, if you go back to basics, you can say, well, regression coefficient is the predicted change in y with a 1 unit increase in x. But x is the product between a dummy code and a continuous predictor. So that's not that intuitive. So let me walk you through this. First, let's go up in the table to the coefficient for working memory. It's 0.12. That's the slope relating working memory to IQ for the control condition because of the way we set up this model. And then, because of the way the dummy codes work, 0.4716, that's the difference in slope between the control condition and threat 1 condition. Let me say that again. 0.4716, that regression coefficient, is the change in slope as you go from control to threat 1. It's just like, don't think about moderation, it's just like when we did dummy coding and we were looking at the change from the regression constant to one of the dummy codes. It was the predicted difference in the means, right? Now, because we're looking at moderation, it's the predicted difference in slopes, not predicted difference in means. And that's what we want to test, right? So it's 0.4716, but let's go out here to the t-values, and sorry, it went over it, the p-values. Both D1 and D2, both of those product terms are significant. Again, I could have predicted that by eyeballing the correlations, right? So there's a significant difference in the slope for the 3 groups. And that is evidence of moderation. So that's the key piece in the output. But again, we can do, to be formal, we can do model comparison. So we simply looked at model 1 versus model 2. As I mentioned, there's a null hypothesis significance test to do that. There's a function in R called ANOVA, which we'll cover in the next lab, where you just compare model 1 and model 2 in terms of the overall amount of variance that they explain in the outcome variable IQ. And it yields an F statistic, which we're going to have a lot more to say about when we get to ANOVA. But for now, again, just you can go out here to the p-value. This F statistic is 4.5. The p-value is 0.01. So there's a significant difference in the amount of variance that these 2 models explain. So that goes hand in hand with the significant regression coefficients that we just saw in model 2. Again, this is just more evidence that, yes, this moderation effect is significant. We can also display that graphically. So remember I mentioned if we have moderation, then the correlations change as a function of group. So why not just plot 3 scatter plots and look at the regression line for each group? Well, we can do even better than that in R. We can just put them all onto one graphic. So this is what it looks like. This top line here, that's the control condition. So remember, the control condition had just a very slight but positive correlation between working memory and IQ. And then the other two groups are down here. They have this really strong positive correlation between working memory and IQ. And the fact that these regression lines are not parallel is evidence that you have moderation. If they're parallel, that indicates that you don't have moderation, right? Because that indicates that the effect is consistent across groups. When it's inconsistent across groups, that's moderation, right? It's the definition of moderation. One more thing I want to highlight about this graphic is you can see that what happens is at the top end of working memory capacity, so working memory capacity is plotted here on the x-axis. At the top end of the distribution, the three groups aren't actually that different in predicted score on IQ, right? The difference is really happening here at the low end of the distribution of working memory capacity. And that's exactly what we predicted. So as I said, we have an experiment going on in my lab that's like this. This is what we hope to see. We don't have this real data like this yet. But the idea here is if you have a very high working memory capacity, then you can essentially buffer yourself against that threat manipulation. You won't be affected by it because you have such a strong cognitive ability in the first place. You won't be as affected as someone down here at the low end who's more vulnerable to that threat manipulation. That's the idea, and that's the interpretation of this moderation analysis.